Distinguished viewers all over the world, welcome to Simplified Maths Class. I am your host, Mr. Mike Omeni. Please, if you have not subscribed to our channel, kindly do that by hitting the red subscribe button. God bless you as you do that. All right, today we have the sine and the cosine rule, part 2. In the previous part of the sine and cosine rule, we discussed the condition for which you are to use the sine rule and the conditions for which you are to use the cosine rule. And we went ahead to solve problems that involved the sine rule. All right, so here in this slide, we'll be solving problems that involve the cosine rule. But don't forget, the sine and the cosine rule are both used in solving triangles that are not right angle triangle. If a triangle is right angle, you either use SOHCAHTOA or Pythagoras theorem to solve it. But once you have a triangle that is not right angle, you use either the sine rule or the cosine rule in solving the triangle. Now, the sine rule is used when two sides and one angle are given in that triangle, or when two angles and one side are given in that angle. That's when you use the sine rule. If you are watching this slide for the very first time, please don't forget to go check out the sine rule and the cosine rule part 1 and be conversant with it before you come down to this slide part 2. All right, so we also talked about the cosine rule and that the cosine rule is used when two conditions prevail in a non-right angle triangle. And the conditions are: number 1, when the triangle has the 3 sides given, which is SSS. And again, when the triangle has 2 sides and an included angle given, which is SAS. All right, so we'll be taking the first one when 3 sides are given. All the formulae for the sine rule have been given in the previous slide, and the 6th formulae for the cosine rule has been given in the previous slide. So please check the previous slide, part 1 of this, and watch it before you watch this part. All right, so we go straight to the point. Here, they say, given the triangle ABC as shown below, we should find the angle BAC. If you look at this, you see that 3 sides of the triangle are given. 1, 2, 3 sides, they've been given. And this triangle is not a right angle triangle. Now, we've been asked to find one of the angles. The only way you can solve this is by the use of the cosine rule. And by the cosine rule, when you're looking for the angle A, the formula is cos A will be equals to B squared plus C squared minus A squared all over 2BC. So if you are looking for cos A, we'll have B squared plus C squared minus A squared all over 2BC. If you are looking for angle here, which is cos B, it will be cos B is equals to A squared plus C squared minus B squared all over 2AC. And if we are looking for this angle C, it will be cos C, and cos C will be A squared plus B squared minus C squared all over 2AB. Please take note of that. We have all the different formulae in the previous slide where you can copy it out for your future references. All right, so how do we solve this? So we are going to have cos A, which is the angle we are looking for. The cos angle at A is the theta. So the cos angle of theta will be equals to B squared. Now understand that this is A. This other side will be small a. The side facing the big A is a small a. Now this is B. The side facing that B is a small b. So here we have small b. And this is C. The side facing the C is a small c. So here is small c. Don't forget that. All right. So it therefore means that your A is 9, your B is 7, and your C is 12. All right. So that's important. Very important. So B squared, B is 7. So that will be 7 squared plus C. C is 12. 12 squared minus A. A is 9. 9 squared. All over 2 times B, which is 7, times C, which is 12. All right, so we have put in the parameters for the A, B, and C. so that we can now have the cos angle of theta is equals to 7 squared 49 plus 12 squared 144 minus 9 squared 81 all over 2 times 7 14 14 times 12 14 times 12 we'll have 168. All right, so we'll proceed by looking for cos B, or the cos angle of theta will be equals to, so we have 49 plus 144 minus 81. So that gives us 112. 112 divided by 168. So 49 plus 144 minus 81 will give us this, all over 168. So the cos angle of theta will be equals to 112 divided by 168. So that will give us 0.6667. 0.6667 into 4 decimal places. So our theta now will be, this cos crosses to become the arc cos of 0.6667. That's this, the inverse of the cos. That becomes the inverse of the cos. That's what it means, of 0.6667. And the inverse of the cos is what we call the secant. All right, so if you want to find the value of theta, all you need to do is to press second function cos. That will give you the inverse of cos. Second function cos of this number. All right, so we have, or if your calculator has shift, use shift of cos. If it's second function of cos. So shift of cos will give you the inverse of cos of that answer. You will now have 48.19 or 48.2. So you have 48.2 degrees. All right, so we've been able to find the value of theta to be 48.2 degrees. Now you've gotten here. You can also look for this angle and as well as looking for this angle. You can also look for maybe one of this angle or this angle. All right, so let's say for instance we want to find the angle at B. Assuming we want to find the angle at B here. So let's call this beta. All right, so let's look for the angle at B. So we can call it beta or we can call it alpha. Okay, let's call it alpha. Assuming we are to look for the angle at B, we are done with looking for the angle theta, which is the angle at A. Therefore, the angle at A, which is angle BAC, will be equals to 48.2 degrees. Now, let's say assuming we also want to use the cosine rule to look for the angle at B. You can also apply it. So let's see how we can do that. Now, by cosine rule, now the cos angle of the angle at B, the cos angle of the angle at B will be equals to, the formula will be A squared plus C squared minus the A squared. Okay, A squared plus C squared minus the B squared all over 2AC. Cos B will be A squared plus C squared minus B squared all over 2AC. So how do we find cos B? So the cos angle of the angle at B will be equals to A squared. A is 9. So that will be 9 squared plus C. C is 12. 12 squared minus B is 7 squared over 2 times our A being 9 times our C, C being 12. Alright, so we are going to have 9 squared is 81 plus 12 squared 144 minus 7 squared 49 all over 2 times 9 18. 18 times 12. 18 times 12 have 216. So we are simply going to have the cos angle of the angle at B is alpha. The cos angle of the angle of alpha will be equals to 81 plus 144 minus 49. So we have 81 plus 144 minus 49. That will simply give us 176. So we divide by 216. Now we have the cos angle of alpha to be equals to 176 divided by 216 will give us 0.8148. 0.8148. So we need to find the alpha angle. In the same like manner, we need to find the alpha angle. Therefore, the angle alpha will be equals to the cos crosses to become the inverse of cos, the shift of cos, the secant of 0.8148. So our alpha angle will be, press shift of cos or second function of cos. So shift of cos of that answer 0.8148, and that will give us 35.4 degrees. 35.4 degrees. Therefore, the angle at B, which is ABC, the angle at B, angle ABC, the angle at B, ABC, will be equals to 35.4 degrees. All right, so please take note. There are two things I want you to note now. We've been able to calculate angle theta, and we've been able to calculate angle alpha. Note that if you're looking for the angle at C, all you simply need to do is to add this one you have calculated to this one you have calculated and subtract those two results from 180. You will get this. Why 180? Because 180 is the sum of the angles in a triangle. So since you have gotten this and you have gotten this, if you add this to this and subtract from 180, you will have the angle at C. It's that simple. You don't need to work for C again using cosine rule. Since you have already defined two of the angles, you can now get this. That's the first thing I want you to note. The second thing I want you to note is that the big angle will always be the angle that is facing the larger side. Take note of that. The larger side will always, the angle that is facing the longest side will give you a bigger angle. Say for instance, if you look at, we have 7 and 9. You will notice that theta, the angle theta, will be bigger than the angle alpha. Why? Because the angle theta is facing a longer side. So it means theta will be greater than alpha. And that's why the result we had for something is bigger than this 35. Why? Because this angle is facing 7. Alright, and this angle is facing 9. So it is expected that this angle will be bigger because it is facing the longest side, or the larger side. Now note that if you are to calculate angle C will be the largest angle because 12 cm is longer than 7 and 9 cm. So it is expected that this angle, of course, will be quite bigger than every other angle in the triangle. Please take note. It's important you note this, because sometimes when you make mistake, this will checkmate you to know whether you actually got the answer or not. All right, so here we've been able to calculate, we've been able to use the cosine rule when three sides of the triangle are given, SSS. All right, so the second condition for which we are to calculate the cosine rule or to use the cosine rule is when we have side, side, and included angle. Okay, so let's see how we can do that. Side, side, and included angle. Assuming we have side, side, and included angle, what do we do? Now, say for instance, we've been given a triangle this way. This is a triangle, and the triangle is A, B, and C. This side was given, let's say, as 15 cm. This other side was given as 12 cm. And the angle in between given as 60 degrees. Okay, let's say 60 degrees. Or let's say 30 degrees. Let's call it 30 degrees. Now, assuming you've been asked to find this side, which is small b, what formula do you have to use? You have to still use the cosine rule, because in this condition, you're having side, side with an included angle. We have side, angle, side. So this is what we call side, side, and included angle, meaning you're giving two sides and the angle in between the two sides given is also given. So when you're giving side, side with the angle in between, the only rule you can use is what we call the cosine rule. And the side you'll be asked to find will be the side that is directly facing the given angle, which is side B. That will be the side you'll be calculating. You'll be asked to calculate. So you apply the cosine rule. Note that if this is A, this is small a. If this is B, this is small b. And if this is C, this is small c. Alright, so let's note that this is B, small b. Here, notice small c, don't forget. And this side is small a, don't forget also. Alright, so with this, we can also find the cosine rule by looking for the side. The other formula for the cosine rule is when you're looking for the angles. But when you're looking for the side, the formula is different. I've given that all in the previous slide, the sine and cosine rule part 1. This is part 2. Alright, so assuming we are looking for the b, so we have b squared, which is this side we are looking for, is equals to a squared plus c squared minus 2ac, the cos angle of b. So our b squared will be equals to a squared plus c squared minus 2ac, the cos angle of b. But if we are looking for a squared, assuming we are looking for this a small side a squared will be equals to b squared plus c squared minus 2bc, the cos angle of big A. Assuming we are looking for c squared will be a squared plus b squared minus 2ab, then the cos angle of the c. So those are the formulae you can use there in the previous slide. But since we are looking for b squared, we have b squared is equals to a squared plus c squared minus 2ac, the cos angle of b. So let us input all this. So our small a is 15. Our small c is 12. Alright, the cos angle of b, capital B is 30 degrees. Okay, so we can apply that. B is what we are looking for. Remember, we are looking for small b. So we have b squared will be equals to, what is our a squared? A is 15. 15 squared plus c, what is our c? 12. 12 squared minus 2 times a 15 times c 12. And then the cos angle of capital B, which is 30 degrees. So this is simply going to be b squared is equals to 15 squared, that's 225. 15 times 15, that's 225. B squared is 225. Alright, so we have 225 plus 12 squared, which is 144, minus 2 times 15 times 12. 2 times 15 is 30. 30 times 12. That simply gives us 360. 360. So the cos angle of 30 degrees. So we proceed again. Now understand that cos 30, we can now input the value of cos 30. The cos angle of 30 degrees will be 0.5. So cos 30 is 0.5. Let's see, cos 30. Alright, 0.8660, sorry. Cos 30 is 0.8660. Alright, it's good I had to confirm. So the cos angle of 30 degrees is 0.8660. So we are going to have our b squared will be equals to, so we simply add 225 to 144. 225 plus 144, that gives us 369. So this will be 369 minus 360 times 0.8660. 360 times 0.8660. So that gives us 311.76. If you times this, you have 311.76. So our b squared will be equals to this minus this. 311.76. So 369 minus 311.76. 311.76. So that will simply give us 57.24. 57.24. Now what will be b? B now will be the square root of 57.24. The square root. So the square root of that, square root of 57.24 will give us simply 7.5657. Our b will be 7.6 meters or cm. I think that was in cm. So our b will simply be 7.6. So as this is 12, this is 15. Your b is 7.6 cm. So whenever you're giving side, and included angle, to look for the side that is opposite that angle that is given, you have to use the cosine rule and apply it this way. is that simple. So these are the two conditions for you to use the cosine rule. For the sine rule, we dealt with it extensively in the first slide of the sine and cosine rule. And this is how we apply the cosine rule to solve problems. Now understand that you need to be very acquainted with the sine and the cosine rule in order to solve problems that involves bearing and distances. And now that we are done with sine and cosine rule, expect that in the next slide we'll be taking bearing and distances. And please, you are not expected to miss that slide. And in order not to miss that slide, simply hit the subscribe button, the red subscribe button, and subscribe to the channel Simplified Maths Class, so that as soon as we produce the bearing and distances, it will pop up on your phones as pop-up messages and you will attend the class. Thank you very much for watching Simplified Maths Class, the sine and the cosine rule part 2. If you enjoyed our class, don't forget to give us a thumbnail. And if you have any question whatsoever, indicate it in the comment section and we'll answer your question. And if, of course, you enjoyed the class, you can also comment that the class is interesting in the comment section. God bless you as you do that. And see you in our next slide, bearing and distances. Have a wonderful day. Cheers.